Hi again. Let's continue with our discussion of complex numbers. In the last video, we talked about the imaginary unit I, and that's given by I squared equals -1, or I equals the square root of -1. We used those to solve quadratic equations that that would give us solutions that aren't real, or maybe did not have solutions before. The number system, right, that we're going to use to solve these quadratic equations is given by the set of complex numbers. And the complex number is a real number plus a real number times I. Here A is the real part and B is the imaginary part. So B is a real number that is being multiplied by I. All right, and we say the set of complex numbers is given by this. This is the set builder notation for it. It's got a lot of fancy math lingo in it. The curly braces simply denote a set. A plus BI is the stuff that we're talking about. So these are all the numbers that are complex, A plus BI. And then the vertical bar here means such that. So we have the set of all A plus BI such that A and B are elements of, little e symbol here, the real numbers. Okay. So this is a larger number set than the real numbers, although you can see that it contains the real numbers because we could set the B part here to be 0, and then we just have A, so A plus 0. These would be all the real numbers. So if we were looking kind of in a Venn diagram looking set here, we could have we'd have the complex numbers, so there's C here, and then inside the complex numbers we have the real numbers. All right, let me find a better pen real quick. Okay. So the real numbers are a subset of the complex numbers. So this is kind of, in a sense, it's a larger set. It will allow us to do a little bit more with quadratics. Okay. Let's practice working with complex numbers. Now, as we can with real numbers, add, subtract, multiply, and divide, we can do the same things with complex numbers. Division requires a little bit extra, but we'll do that in the next video. So here's some addition. There's an addition, a subtraction, a multiplication, and another multiplication. Let's work these out. So here we have two complex numbers, 5 minus 2i, plus the other complex number, -3 plus I. And the first thing you want to do when you look at a addition or some type of arithmetic operation with complex numbers, identify the real part and the imaginary part. So this first complex number, the real part is 5, and the imaginary part is -2. For the second complex number, the real part is -3, and the imaginary part is 1. Right? So there's a 1 times I there. It would not be 0, because 0 times I would be 0. That would give us just a number that's simply real and does not have any imaginary part. Okay, now the way we add complex numbers is to add the real parts together, and then add the real or the imaginary parts together and multiply by I. So for this addition, we'll take 5 plus -3 and to that we will add -2 plus 1 times I. All right, 5 plus the -3 is 2, so we have 2, and then we have 2 plus 1, which is -1, so 2 minus I. So again, add the real parts, add the imaginary parts times I. Okay, that's addition. Let's look at subtraction. For subtraction, again, we want to identify the real parts and the imaginary parts. But what we can do is treat this like a binomial and distribute the negative. Then it turns into an addition. I think that's the best way to handle it. Otherwise, we'd be subtracting the real parts and subtracting the imaginary parts, which does work, except we may have a bunch of negative signs floating around. Let's evaluate this first. Okay, so we'll have -1 plus 4i. Then we have minus -2, so that's plus 2. And then minus plus I would be minus I. All right, now we've written it as an addition, and so we can add the real parts together. So -1 plus 2 is 1, plus 4 minus 1, 3 times I. Okay, let's look at multiplication. -1 plus 4i, so -1 real, 4i imaginary, times 2, -2 plus I. So -2 is the real part, 1 is the imaginary part. Okay, these can be treated as binomials, and we know that we need to either FOIL or, in any case, distribute this out to multiply. All right, so let's go ahead and FOIL. So we have -1 times -2. And we'll add -1 times I. So the outer, that's first, outer. Inner, we'd have 4i times -2. And then last, so 4i times I, 4i squared. All right, so first, outer, inner, last. Okay, now let's simplify this. -1 times -2 is 2, minus I, and we have -2 times 4i, so minus 8i, and then plus 4i squared, we know that I squared is -1. So 4i squared is really just minus 4. So we have 2 minus I minus 8i minus 4. We can combine the like terms now. 2 minus 4 is -2. -I minus 8i is -9i. So -1 plus 4i times -2 plus I is -2 minus 9i. Okay, let's work on this last one. I have 2 plus 4i quantity squared. This problem is just like the last one. The square means to multiply this complex number by itself. So this is really saying take 2 plus 4i times 2 plus 4i. Okay, so if you'd like to multiply this out, why don't you pause the video right now and go ahead and give that a try. Okay, how did it go? Well, we want to FOIL out just the same way. 2 times 2 is 4. So first, outer would be plus 8i, inner would be plus 8i, last would be 16i squared. So we have 4 plus 16i minus 16, and 4 minus 16 is -12. So -12 plus 16i. All right, so we have looked at the set of complex numbers, and we have performed 3 different operations with complex numbers: adding them, subtracting them, which is really just taking the opposite and then adding, and then multiplying. And to multiply, we need to use FOIL. In the next video, we'll look at dividing complex numbers, which needs a little bit extra, right, before we can do that.